Hello everyone, my name is B. Jagdish, rule number 219518046 from ECA. My DSD concept video topic is basic memory devices. So let's get started. Introduction. A memory is just like a human brain. It is used to store data and instruction. Computer memory is the storage space in computer where data is to be processed and instructions required for processing are stored. The memory is divided into larger number of small parts. Each part is called a cell. Each location or cell has a unique address which varies from 0 to memory size -1. For example, if computer has 64K words, then this memory unit has 64 into 1024 equal to 65536 memory location. The address of this location varies from 0 to 65535. Memory is primarily of two types: internal memory, external memory. Internal memory, cache and primary main memory. External, magnetic disk, optical disk, etc. Speed increases up as we move up. CPU registers, cache memory, main memory, magnetic disk, optical disk, magnetic tape. Internal memory, external memory. Characteristics of memory hierarchy are following when we go from top to bottom. Capacity in terms of storage increases, cost per bit of storage decreases, frequency of access of the memory by CPU decreases, access time by CPU increases. RAM. The RAM constitutes the internal memory of the CPU for storing data, program and program result. It is read-write memory. It is called random access memory. Since access time in RAM is independent of the address to the word that is, each storage location inside the memory is as to reach as other location takes the same amount of time. We can reach into the memory at random and extremely fast, but can also be quite expensive. RAM is volatile. Data stored in it is lost when we switch off the computer or if there is a power failure. Hence, a backup unusual power system is often used with computers. RAM is small, both in terms of physical size and in amount of data it can hold. RAM is of two types: static RAM, SRAM, and dynamic RAM, DRAM. Static RAM, SRAM. The word static indicates that memory retains its contents as long as power remains applied. However, data is lost when power gets down due to volatile nature. SRAM chips use a matrix of 6 transistors and no capacitors. Transistors do not require power to prevent leakage, so SRAM need not have to be refreshed on a regular basis. Because of the extra space in the matrix, SRAM uses more chips than DRAM for the same amount of storage space, thus making the manufacturing cost higher. Static RAM is used as cache memory, needs to be very fast and small. Dynamic RAM, DRAM. DRAM, unlike SRAM, must be continually refreshed in order for it to maintain the data. This is done by placing the memory on a refresh circuit that rewrites the data several hundreds times per second. DRAM is used for most system memory because it is cheap and small. All DRAMs are made up of memory cells. These cells are composed of one capacitor and one transistor. ROM. ROM stands for read-only memory. The memory from which we can only read but cannot write on it. This type of memory is non-volatile. The information is stored permanently in such memories during manufacture. A ROM stores such instructions as are required to start computer when electricity is first turned on. This operation is referred to as bootstrap. ROM chips are not only used in the computer but also in other electronic items like washing machine and micro oven. Following are the various types of ROM: MROM, PROM, EROM, double EROM. MROM masked ROM, PROM programmable read-only memory, EROM erasable and programmable read-only memory, double EROM electrically erasable and programmable read-only memory. MROM masked ROM. The very first ROMs were hardwired devices that contained a pre-programmed set of data or instructions. These kind of ROMs are called as masked ROMs. It is inexpensive ROM. PROM. PROM is read-only memory that can be modified only once by a user. The user buys a blank ROM PROM and enters the desired contents using a PROM programmer. Inside the program chip, there are small fuses which are burnt open during programming. It can be programmed only once and it is not erasable. EROM. EPROM. The EPROM can be erased by exposing it to ultraviolet light for a duration of up to 40 minutes. Usually an EPROM eraser achieves this function. During programming, an electrical charge is trapped in an insulated gate region. The charge is retained for more than 10 years because the charge has no leakage path. For erasing the charge, ultraviolet light is passed through a quartz crystal window lid. This exposure to ultraviolet light dissipates the charge during normal use. The quartz lid is sealed with a sticker. Double EEPROM. The EEPROM is programmed and erased electrically. It can be erased and reprogrammed about 10,000 times. Both erasing and programming take about 4 to 10 milliseconds. Any double EEPROM, any location can be selectively erased and programmed. Double EEPROMs can be erased one byte at a time rather than erasing entire chip. Hence, the process of reprogramming is flexible but slow. Thank you.